right, so this podcast is pretty short. It's really a definition thing, but isomer is kind of two different word, parts. Iso means same, and mer means part. So like a mermaid is part fish, part human. So isomers have the same parts, okay? So if I were to draw out, and I'm just going to leave the H's off here, but if I were to draw pentane, okay, so I know it's 5 in a row because I'm drawing pentane. And we're just going to do dashes, I guess, for H's. So I know this formula would be C5, and I'm going to have an H there, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12 is the formula for pentane. Okay? So are there other ways I could draw out 5 carbons and 12 hydrogens, so they're all single bonds, but that don't look like that? Okay? And the easiest way to do this would just be to essentially, and let me change my pen to red, if I were to lop this carbon off. Okay? So where else could I put it? Okay, so just underneath it, we're going to do 4 in a row. 1, 2, 3, 4. And then where could I put this? And someone might say, oh, you could put it right here. Okay? But if I put it right there, that's still 5 in a row. Okay? I just bent my last carbon. So I'm going to erase those. But if I put it here, okay, my longest chain is only 4 in a row. Okay? And I've got a methyl group hanging off of 4. So let's just see if this still has 12 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this also has the formula C5H12. Okay? But if I identify my longest chain, here's my longest chain. So instead of being a pentane, this is really a butane. But this butane has a methyl group, so I have a methyl butane. And if I name this correctly, it's going to be on the second carbon, because if I count from right to left, this is the second carbon. If I count from left to right, it's the third carbon. So 2-methylbutane and pentane, we would say these two compounds are isomers because they have the same parts, but they actually make 2 distinct compounds. Okay? So can I make yet another compound that has the formula C5H12? And the answer is yes. And what I could do to do that is, let me see if I can erase these red lines. But what if I were to knock off, if I were to knock off this carbon, then I'm back to a butane, and no matter where I put this, it's going to be somewhere on my butane again. So I'm not going to do that. But if I were to lop off this carbon, okay, let's just draw what's left really quickly. So I'd have 3 C's in a row on top and a C below. So I could put this carbon that I just kind of cut off maybe on top. Okay? And once again, let's see if I give all of my carbons 4 bonds, if everybody ends up with 12 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So once again, all 3 of these drawings have the same formula, okay, but they're distinct compounds. So again, if I name this bottom one, I really just have a propane now because I have 3 in a row. And this propane has 2 methyl groups, so it's a dimethylpropane. And both of my methyls happen to be on the second carbon, so a 2,2-dimethylpropane. So the easiest way to determine if something has an isomer is just cut a carbon off the end, and does it fit somewhere else? Okay. So notice there's no isomers for methane, ethane, propane, or butane. Because if I start with a butane and I knock this last carbon off, I guess with a butane I could have a 2-methylpropane. Okay, so there's no isomers for methane, ethane, propane. But my first isomer could be with butane. And then the longer my chain gets, the more and more possible isomers an octane has. compared to a pentane.